All right, today we're going to talk about dilations, okay? And dilation is a type of transformation. Now, we've talked a lot about transformations this year. Specifically, we talked about rigid transformations. And if you remember, a rigid transformation. So, in a rigid transformation, the shape stays congruent. Okay, so that means all the side lengths stay the same size, right? We talked about how you can flip it around, you can move it, you can do all that. That's not changing the actual size of the shape. So we've had three rigid transformations this year that we've worked a lot on, and those are translation, reflection, and rotation. Okay. And today we're going to talk about a fourth transformation that's actually not a rigid transformation, and that's a dilation. Okay. So in a dilation, the shape grows bigger or smaller. So you might have heard of the word dilate before, like your pupils dilate, right? And so a dilation, you have a shape and you dilate it. So there we just made it bigger. That would be a dilation, or you could shrink it and make it smaller. Okay, that would also be a dilation. And so this kind of fits with similarity, which this is about, because when you do a dilation, your shapes stay similar. Okay. So when we do dilations, just like before, we're still doing it in terms of having a scale factor. And the scale factor is telling you how much bigger your shape is going to be. So if we want to dilate triangle ABC by a scale factor of 2, that means we're going to make our triangle twice as big. Okay, so here's triangle ABC over here. So I'm going to create a new shape. Oh, that wasn't good. Let's try again. I'm going to create a new shape. It doesn't have to be perfect. That I'll call A prime, B prime, C prime. And we're dilating it by a scale factor of 2. So that means all the side lengths are growing by 2. So we see that these two side lengths right here are both 3. So now these two side lengths will both be 6. And then this side length is 2, so this side length will be 4. And that's what it means to basically do a dilation. So this is not very different than kind of what we were talking about, like all of last unit for part 1, okay? So you can shrink them too. So if the scale factor is less than 1, like here we have a scale factor of 1/2, that means that our shape is getting smaller, okay? So here we would have just like a little trapezoid, and we're cutting all the side lengths in half. So this would be 5, this would be 7, this would be 7, and this would be 8, okay? So that's kind of what you're doing when you're doing a dilation. So hopefully that makes sense. Now, basically what you're going to be doing for the rest of this is getting to dilations on a grid, okay? So I'm going to show you 3 examples, and then I want you to try these ones here, okay? So the center of dilation, this is basically where like all the points are moving away from, okay? So we're going to be talking about basically every dilation having a scale factor and every dilation having a center, okay? So if we want to dilate this square, first of all, we're going to do it by a scale factor of 2. So that means everything's going to be twice as big, and it's going to be centered at point B. So if you think about when we had rotation, a center of rotation, if you're on the center, that point does not move. Okay, so B is actually going to stay the same. And all of our other points are moving away from B by basically by twice as far as they are right now. Okay. And the way that you're going to do this is that some of your points are going to be along a straight line from B. Actually, here they all three are. And so you want to count how far away they are from B right now. So if I'm looking at C, this is 1, 2, 3, 4. Okay, so C is 4 spaces away from B. And that means my new C is going to be 8 spaces away from B because we're going to double that. So I'm going to go 1, 2, 3, 4 again. And there's my C prime. Okay, so I can draw this line right here. And that'll be the bottom of my shape. So we can see that the length has doubled. We're going to do the same thing with A. 1, 2, 3, 4. So we want to double that. 5, 6, 7, 8. So A prime will be up here. And now D, there are a couple ways that you can do D. Like we know kind of basically that D is going to be up here because it has to be like in line with A and C, right? But also you can kind of draw a line straight to D. So this line is going diagonal. So we're kind of going 1, 2, 3, 4 diagonal spaces away from B. So we know that if we double that, we're going 5, 6, 7, 8 diagonal spaces away. And so D prime would kind of be up there. So that's another way that you can figure out kind of the third point. If it's not in a straight line, it could be in like a straight diagonal line. And when we're done, we draw all of our shapes and boom. So we have just created a dilation of our square by a scale factor of 2, okay? Now we're going to do the same thing, but we're going to do it from point A, just so that you can kind of get a feel for how the center kind of affects where the shape is going to be. So now A is not going to change. Okay, now we're going to have A prime right here. So we're still doing a scale factor of 2, and it's going to be centered at point A. So now we're looking at how far away is everything from point A. Well, we've got 1, 2, 3, 4 to D. So if we go 5, 6, 7, 8, so we know that D prime is going to be right here. We can do the same thing for B. We've got 1, 2, 3, 4, 5, 6, 7, 8. And finally, if we do C, we've got 1, 2, 3, 4, 5, 6, 7, 8, and C prime will be down here. So you can see by looking at these two examples that where the center is, it doesn't affect how big the new shape ends up being. It just kind of affects where it goes, right? So when we had B, our shape kind of went in this direction, whereas when our center was A, our shape went in that direction, okay? Now, the last thing that we're going to talk about, this should not say centered at the origin. Sorry, guys. This should say centered at point E. So we're going to talk about what do you do if the center is like in the middle of the shape, if it's not one of the vertices? Well, you're pretty much just doing the same thing, right? So here we've got this point in the middle. That means everything's just moving away from E. So D is 2 diagonals away from E, so we can go 1, 2. So E prime is going to be up here. And it's actually the same case for all the shapes. Like they're all 1, 2, 1, 2, 1, 2, right? So we can just kind of move them all 2 diagonal spaces away from E. So you can see here that when your center is kind of in the middle of the shape, your shape kind of expands in all directions. So that's really what you're doing here. So you've got a couple triangles here that I want you to do as well. You're just doing it the same way, okay? This one doesn't have anything. I'll make sure to go back and fix that. You're just counting how far away everything is from wherever you are going to do your dilation from, okay? So hopefully that made sense. If you have questions, I'm sure Mrs. Palmer will be great help, all right? Have a great day, and I will see you later.